Hello, everyone. Welcome to session 6 of our training series. As you all know, my name is Amber McCullum, and I will be joined by Cindy Schmidt for the exercise portion for today. Just as a review, this series will be provided via GoToWebinar each Tuesday and Thursday of October from the 6th to the 29th. All of the course materials can be found at the UTTC website shown here. And also, please refer to that for the forums and guidance on the continuing education units. Also on the website is where you'll be able to find all of the lectures, as well as the course materials, so the exercises and the data. And again, as we have done with the past sessions, you should have downloaded all the materials for the exercise today so that you can either follow along with the demonstration or complete it on your own time. As we have done, this training series is a mix of lectures and hands-on exercises. We are conducting all of the demos in ArcGIS Pro, but you have the option to use Desktop and QGIS. And as we've done in the past, each week we'll focus on a different region. So for today's session, we are focusing on this week, it's change detection and time series. And next week, we will review some useful web tools that use remote sensing. Actually, the exercise for today will be a web tool as well, looking at time series. So for today's session, we are going to review the benefits and limitations of the use of time series of satellite imagery for various applications. We will then discuss a few different methods and algorithms for time series analysis, and I will provide a few examples of useful tools for time series. Then Cindy will demonstrate the AppEEARS tool for the time series exercise. You can either follow along today or complete the exercise on your own time, as I mentioned. So let's start off with an overview of time series for remote sensing. The use of multiple images over time allows us to identify various types of change on the ground. When these changes happen over a series of days, months, or years, the use of many different images allows us to view the progression of these changes. This is particularly useful for things like gradual changes, like decreases in forest health due to mountain pine beetle infestation, for example. There is also the advantage of having a long record of satellite imagery from Landsat and MODIS. Additionally, time series analysis has become more prevalent in recent years with the advent of cloud computing and improved processing, whereas this used to be quite a cumbersome process. There are many types of time series analysis. We can view annual or seasonal trends, such as vegetation health. We can view gradual changes, like the pine beetle example, or abrupt changes, like a forest fire. We can view anomalies, which could be related to something like drought, or generate environmental descriptors to evaluate changes in things like species habitats. Annual trends occur over many years. Here's an example of changes in vegetation health in China on the left. In this example, the leaf area index, or LAI, was calculated for each year from 2000 to 2014, and changes in the LAI could be related to water availability. Seasonal trends are often driven by environmental factors like temperature or precipitation. In the example here on the right, you can see changes in seasonal snow cover with MODIS from the winter to summer months. Here are a few examples of gradual versus abrupt changes. As I mentioned, gradual changes could be due to something like insect infestation or land degradation that can occur over many years. Abrupt changes like wildfires or deforestation are marked by a distinct change in the land surface. The figure on the right shows an abrupt change in NDVI, or vegetation health, from Yosemite National Park, where the wildfire occurred. Then we see gradual vegetation recovery after the fire as the vegetation grew back. So this is an example of both of these types of changes. Anomalies are essentially the difference from average conditions. This image indicates NDVI anomalies from March 2019. This could be used to identify drought and how that might affect agricultural security. Other examples of the use of anomalies include monitoring changes in snowpack or groundwater. Satellite images can also be used to generate maps of environmental descriptors, like those shown here, related to habitat health. So for example, vegetation health, along with other habitat metrics like productivity, could be used to identify bird species richness, for example. So now let's move on to describe a few of the methods for analyzing imagery from many dates. Simply graphing the reflectance values or indices like the NDVI at a specific pixel or within a region can be a great first approach at identifying changes over time. So things like the seasonality of NDVI can be tracked, like the image on the left, or the wildfire disturbance and regrowth example we just showed you on the right. So we will work with these types of figures for the exercise today. Decomposition techniques are a bit more complicated, but they can be used to pull apart changes or variability in the imagery due to the effects of changes over multiple time periods. So for example, you might see a seasonal pattern in vegetation health in the summer compared to the winter. But there might also be a longer-term fluctuation associated with something like increases in precipitation due to the El Nino Southern Oscillation over a period of maybe 2 to 5 years. So with these types of methods, you could identify the effect of the seasonal trends as well as El Nino on vegetation over long periods of time. One of these examples is called the Breaks for Additive Seasonal or Trend Method, BFAST, and it can be used in something like an R package. One of the most common methods for identifying change in satellite imagery is with the land trender algorithm. And this was developed by Robert Kennedy's lab at Oregon State University. This method recognizes that change is not generally a contrast between two dates, but a continual process operating over multiple timescales, and therefore can be used for short and long-term events. Land trender generates one yearly composite image and forms a Landsat time series stack across a date range of interest. So Land trender really focuses on three primary components: the use of yearly data, analysis of each pixel from each year within the stack, and the ability to temporally segment events that preserve both short and long-term changes. So we can see both of these types of things happening. So first, in the land trender program, land trender algorithm, Landsat mosaics are created to eliminate issues with data gaps, snow, clouds, smoke, or shadow. For each image, some processing is applied, and then each image is normalized. And this is really important to create one yearly image that is similar across many different time periods. Once we have a stack of images that have been properly evaluated, temporal segmentation is used to capture both those abrupt and gradual changes. By temporal segmentation, we refer to modeling a pixel's spectral time series as a sequence of straight line segments that capture the broad features of the trajectory, which eliminates noise or the small variations in the data without sacrificing the actual changes that we're seeing. So here's an example of the best fit model for multiple pixels from an image in the Cascades in Oregon. So along the top of this figure, you can see three dates from 1984, 1995, and 2004 with 6 pixels selected. Along the bottom, you can see the normalized burn values normalized burn ratio, NBR, values from each pixel across time from 1984 to 2006. The figure displays each value from each pixel for each year. The black lines represent the model with the best fit for each pixel. Notice that the number of segments differs depending on how change occurs with each pixel. So this example represents various types of change that you can observe. For example, pixel 1 is a region that shows slow-moving disturbance caused by insect infestation. There appears to be a gradual decline from about 1984 to 1994, then moderate recovery. Pixel 5, by contrast, shows a stable forest that had a wildfire event around 2007 with that sharp decline. So by examining both the short and long-term changes, we can see multiple types of changes in a dynamic ecosystem like this. There are several other algorithms for identifying change, and we will just mention a few briefly here. The first one is Vegetation Change Tracker, or VCT. And this is another algorithm that's similar to Landsat. However, it's only used for forested regions and is really best for short-term discrete events. It has a two-step approach where each image in a Landsat stack is analyzed and the clouds and other issues are masked out. Then it uses the normalized burn ratio that we mentioned to create an integrated forest score, or likelihood of the pixel being a forest. So again, this type of algorithm may be really useful for something like wildfires. The exponentially weighted moving average change detection algorithm was really developed to address issues of data gaps. So again, if you're in a region that has a lot of cloud cover or data quality issues, this may be useful. This also uses a time series approach, and it focuses on the residuals, which is a form of decomposition that we discussed earlier. And this process allows for identification of, again, more high magnitude disturbance like fires. And this image here shows a wide range of change from growth in green to thinning in yellow and removal of trees in red and orange. One interesting thing about this image is the line that goes straight across the image is actually a tornado path near Tuscaloosa, Alabama. The image trends from regression analysis is also a pretty simple approach focused on a simple linear regression of Landsat images on a pixel-by-pixel basis. This can be used for all types of woody vegetation. This works best for gradual trends. So this is useful for forest disturbance that happens over many years. And it's effective on many different vegetation types, from grasses to brush to forests. So these images here show NDVI comparisons from Nebraska. And finally, the final method that we will discuss is the continuous change detection and classification. So this focuses on multi-year data of phenology using a model that includes seasonality, trends, and high magnitude events. As with many of the other algorithms, it also has a process for removing clouds. And in this technique, it's a little different because land cover classification is also conducted at the same time. And change over time is identified with that land cover classification. And this is used in the National Land Cover Database that we showed when we were talking about land cover classification last week. So this is also really useful for identifying discrete events like fires with high magnitude. So now that we've reviewed some of the methods for time series analysis, let's take a closer look at a few tools that you can use. These tools can be used to visualize or analyze change. Google Earth Time-Lapse, for example, is shown here and is really great for visualization. If you go to this link here, you can see a bunch of examples. This is one of Glacier Retreat in Alaska. Other tools also allow for analysis. These include Trends.Earth, the Google Earth Engine application for the land trender algorithm that we spoke about, and AppEEARS, which is what we will focus on for our exercise today. So here's an example of urban growth from Google Earth Time-Lapse. You can pick a region like Las Vegas and view the historical imagery. Then you can view all the images for this region that Google Earth has compiled using a time slider. So we can view an image of Las Vegas from 1984, where you can see the grays and the purples indicate urban extent. Then you could move forward to 1992 to show how the city has grown. Then look at 2004. And finally, we can look at 2016 and you can really see how the city has grown. So this is just one example of ways to start to visualize these types of time series changes on the ground. Another really useful tool is called Trends.Earth. This project, created by Conservation International in collaboration with many other groups, focuses on land degradation and urban growth as they relate to the International Sustainable Development Goals, or the SDGs. In particular, SDG focuses on life on land. So the project has developed methods and guidance on assessing land degradation using remote sensing, and has implemented these methods using QGIS, which, as some of you know, is a free and open source software. So within this tool, you can do things like download and visualize remote sensing data, map and calculate vegetation indices and study trends in vegetation productivity, compare different types of satellite imagery, also include ground-based data, and compare the ground data with Earth observations. So much of this tool focuses on these three components: land productivity, land cover, and carbon stocks. So for example, for the land cover portion, Trends.Earth allows the user to take many dates of images, in this example, 2001 to 2015, and create a transition map. So transitions from one land cover type to another. And then you can identify a set of criteria to evaluate the various transition types and create a map of potential land degradation. So for example, you could have land cover types like tree covered, grassland, and cropland. And Trends.Earth can help you map which category the land cover types are in, and if they're in better or worse condition, or if they've transitioned entirely to a new class. So that was just one example of the use of Trends.Earth, but there are many others like urban mapping, as well as looking at land degradation through the website, as well as through the use of QGIS. One thing to note is that I don't believe that Trends.Earth works for the most recent version of QGIS. You might have to double check the version of QGIS that it works with if you're interested in downloading this plugin. So the website is shown here as well. So we talked a little bit about the land trender algorithm, and land trender is also available in a GUI interface application through the use of Google Earth Engine. So you could run land trender either through JavaScript if you're someone who is familiar with coding, but if not, you can run it through this interface and select some of the properties of how to run your algorithm, create maps in a really efficient way. So you could create something like your annual composite maps and look at different indices like the normalized burn ratio to identify change. Within the Land Trender program in Google Earth Engine, you have three different options: a pixel time series plotter, a change mapper, and the fitted index delta RGB mapper. So the pixel time series plotter, the interface looks like something like this. Some of the parameters are defined on the left, and there are plots generated on the right, such as the NBR or the NDVI. So this is really useful for exploring and visualizing the spectral temporal scale of a pixel, and for comparing the effectiveness of these indices for identifying landscape change over time. You can see there's data from the 1980s up into the 2000s here. And so here's a randomly chosen pixel near Prospect, Oregon, where some changes can be seen in terms of potentially logging or disturbance. In the change mapper, once you select a location, 3 maps will be produced: the year of change detection, the magnitude of change, and the duration of a change event. You also can view pre-change and post-change spectral values in a particular pixel. So in this image, the year of detection is displayed, meaning the year where some type of disturbance happened. And each year is identified as a different color, and you can display the legend and take a look at when disturbance was happening. So you could see there have been many years of disturbance, potentially with a large fire in the center, and potentially with logging or agriculture disturbance happening on the left side of the image here. The fitted index delta RGB mapper is really designed to identify areas of change or non-change over time. So each color, red, green, and blue, is assigned to a year within the spectral data, and then those data are displayed together in an RGB image by weighting the amount of change occurring in each year. So this is the same location as the location where the change mapper image was just shown. And you can see high variability in some of the clear cutting, forest disturbance, and then potentially agricultural development. So if you're interested in learning more about Landtrender with Google Earth Engine, I've included a link here to a previous training that we conducted with NASA's RSET program. And we also have a hands-on exercise with this tool included there. So it's all freely available. You can click on that link and get more information there. So the final tool is the one we'll be focusing on for the exercise today, called AppEEARS. AppEEARS stands for the Application for Extracting and Exploring Analysis-Ready Samples. And this is a really simple and efficient way to perform data access and transformation. It enables the user to subset data spatially and temporally, and allows for analysis in the tool prior to downloading a lot of data. Within AppEEARS, you can submit sample requests to obtain values of remotely sensed products at specific points or for larger areas using polygons. You can also create interactive visualizations with summary statistics and the sample results provided within the application to allow you to preview and interact with the data before downloading. So in this example, this is an image from Cape Town in South Africa, where they had these really major reservoir declines between 2014 and 2018. And then along the bottom is an NDVI time series, where you can see the NDVI values surrounding the reservoir were much higher prior to the drought in 2014 than they were in 2017. So for this exercise, Cindy is going to walk you through an example of mountain pine beetle infestation in the Black Hills. And we'll be using point locations and this similar type of analysis within AppEEARS. So now we will move on to exercise 8, time series analysis. And don't forget to join us for our next session on Tuesday, October 27th, where we will focus on more web tools for remote sensing. So now over to you, Cindy, for the exercise.
Okay, hi everyone. This is Cindy Schmidt, and I will be walking you through exercise 8 using AppEEARS to look at some time series data. And as you can see, I have a graphic up right now that shows some mountain pine beetle that occurred in the Black Hills National Forest between 2010 and 2016. And so just for orientation, if you can see it, on the right-hand side is Rapid City, and then the Custer State Park is just south of that. So it's a beautiful part of the country, but they have also been hit hard by mountain pine beetles, which has caused a lot of tree mortality. And then on the legend, you can kind of see the time frame of when that occurred, with the peak really occurring around 2013. Although it looks like it sort of has moved south and north from the main infestation that occurred a little bit later, 2015, 2016. But a lot of the points that we're using today are in those kind of green areas where the peak was in 2013. So we'll take a look at that. All right, so I'm gonna bring up AppEEARS. So as Amber mentioned, we're going to be using a web-based tool called AppEEARS. And this is a fantastic online tool. First of all, we don't need any software to analyze the data, which is awesome. The only thing that we will need is Excel spreadsheet or some kind of spreadsheet application. The other thing I want to note is the AppEEARS is run by the Land Processes DAC, which is located in Sioux Falls, South Dakota. So not too far from our little study area here. And the folks at the DAC are awesome. So if you have questions about AppEEARS or anything else that we're going through today that we can't answer, I highly recommend that you contact the DAC. They're super helpful, and they've created not just AppEEARS, but there's a lot of different tools that are available for processing data remotely. So in addition to what we're doing today in the exercise, I highly recommend that you take a look at this website and see all of the other great things that you can do. The other thing I do want to note is that we will be working with MODIS data. This is a new data set that we haven't worked with yet, so I'll be describing that as we move along. So the first thing we want to do is get to the AppEEARS website, obviously. You will note that you will need to get you will need to sign up for an account, a NASA Earth Data account, in order to actually run the processing on this. So everything's free, and we have the website listed on the exercise on the very first page of the exercise, but you will need to sign up for that account before you'll be able to do any work on AppEEARS. So the first thing we're going to do once we get to the web page is, I'll show you that, is we're going to extract point samples. Okay, so I'm going to bring that up. Before I do that, I do want to show you the Excel file. So this file comes with your exercise. Hopefully you all have this one. And it's simply a list of 8 sites. So the names are on the far left-hand column, and then their latitude and longitude locations in the B and the C column. And that's all we need. And so these are points. So these are pixel locations where bark beetle has caused tree mortality in the Black Hills National Forest. And this is the format that we'll need. Okay, so the first thing we want to do is start a new request. So if you click on that, then you'll see this new web page that comes up, and then we'll want to give what we're doing a name. So we can call it something like Beetle 1. You can give it any kind of name that you want. And then the next thing we're going to do is we're going to take that file, which was a CSV file, by the way, and we can drop it into this box. So I'm going to go ahead and do that. I'm just going to see, I basically just take this and drop it right into that box. And the really cool thing is that you'll see the coordinates pop up on the right-hand side here. So this should look exactly like the file, the Excel file that I just showed you. Now, one thing to keep in mind, and this is actually a mistake that I made with this particular file, is that I had forgotten to put the negatives in there for the longitudes. And so the really great thing is that those points will also show you where they occur in the world here on the map below. And it was in a very different part of the world than it was supposed to be. So heads up to make sure if you need to put the negatives in there, don't forget to put those negatives. Okay, so once we have the file in there, we want to put the start date and the end date of the time that we're interested in. So I'm going to pick the month of July, since that's sort of it's a peak period for looking at tree mortality in that region, but it's also a time when there's less cloud cover than other parts of the year. And I'm going to do it for the whole month. Because the data that we're actually going to look at is monthly. And I'll go ahead and put, actually I may have to redo, but that's okay. Okay, I'll say the month of July. Now note that the start date is 2020 and the end date is 2020. So we want to change that to include the years that we're interested in. So we need to click on this little guy here, is date recurring. And we want to move the slider bar. So we have the years 2005 to 2019. So notice when I did that, the start date and end date went away. So I probably should have done that first. So we'll put in the July timeframe again. July 1st through July 31st. Okay, you can choose different start dates. You can choose, multiple months, whatever you want to do, but we're just going to kind of keep it simple at this point. Okay, so now what we want to do is choose the satellite imagery that we're interested in. And it has a really great search tool down here. So if you just type in vegetation, what you'll see are all the different data types that are vegetation indices that are available, mostly MODIS data. So I'm just going to scroll down and I'll show you. There's a few. There's AppEEARS. There's a bunch of them, and you can choose any of them. What you'll notice is with MODIS, it is a much coarser spatial resolution than Landsat. So the best spatial resolution you're going to get is this 250 meter, and it's every 16 days. So it's a composite image every 16 days. Or you can get 500 meter, or you can get a kilometer. And if you scroll down, so Terra is one satellite, and then Aqua is another satellite that also holds MODIS. So it's the same data. Sometimes they're just kind of different. You get different time periods. And then AppEEARS is the replacement for MODIS once MODIS goes away. So you can choose any of those vegetation indices. And we talked about what NDVI and EVI are before. what we're going to choose for this particular exercise is going to be the MODIS, the Terra MODIS 1 kilometer monthly. So it's fairly coarse resolution. Again, you can go higher if you want. The reason is because we just want to look at 1 month and then the average of that month over time. Just to keep things simple. So if I select that, then you'll get within that data set, there's actually several data sets. There's EVI, there's NDVI, and then there's some reflectance data, which you can see in a bunch of other stuff. If you scroll down, we're just interested in the NDVI, which is 1 month, 1 kilometer monthly NDVI right here. So I'm going to click the little plus sign. And that's all you have to do. And then what you do at this point is you submit the job. And what will happen is that you'll get an email that says that the job's been submitted, and then when it's finished, you'll get an email saying it's finished. Now, when I did this last week, it took like seconds for it to finish. It really is dependent on what else is going on the system at a time. For example, if all 150 of you were to submit a job at once, the job would probably go a little bit slower than if it was just 1 or 2 of them. So just a heads up on that. So then to check the status of the job, you can go back to the top of the web page and you click Explore. And you can see I have actually a bunch of jobs that I had submitted over time. And this Beetle 1 is a job I've submitted, I did last week. So that's the one that we're going to work with. You'll notice that it tells you what the status is here. So if it's not done yet, it'll say pending or something like that. And then when it's done, it'll say done. So this is another way you can check on whether this job is finished or not. So let's go ahead and take a look at it. There's several ways we can look at these, the results. One is online. There's some great tools that AppEEARS has just to check out your data online. So I'm going to click on my request. And what you'll see is some more information that'll pop up on this job. So at the very top, you'll see 3 tabs: temporal comparison, layer comparison, and categorical overview. So we're going to start with the temporal comparison. You can look at one site at a time. So if you remember, we put in information for 8 different points. So let's just start with this first point. Let's look at just the good quality points, and we'll talk about the quality of the pixels in a minute. And then, of course, there's only one layer because we only requested data from the 1 kilometer NDVI. So if you scroll down, you'll see this time series chart. And I'm just going to go ahead and click on the add line right here. And you'll immediately see a pattern that has occurred. So on the y-axis are the NDVI values, and if you remember, those values range from -1 to +1, and so the closer it gets to 1, the more vegetation there is. And so, as you can see, these values range from about 0.66 to about 0.77. And then, of course, on the x-axis is the time. So the years 2005 to 2019. And it's pretty clear that somewhere between around 2013, 2014, there was a big drop in NDVI at this particular point. And that is because of the tree mortality. And then it's slowly starting to recover over time between about 2014 and 2019. And then just also remember that this is a 1 kilometer pixel. So it's covering 1 kilometer in space in the surrounding area. Okay, and so you can go ahead and look at your different points. So right now we're just looking at point 1. If we look at point 2, we're going to see something similar, where there was, again, a drop a little bit earlier in time, but there was a drop in the NDVI pretty low. And then something else happened, it looks like maybe late 2016 for the second point, and so forth. We'll just take a look at point 3. Same thing. So probably pretty even NDVI for the first few years, and then between 2013 2014 there's a huge drop, and then now it's starting to recover. So it's a really great way, very easy way to take a look at NDVI trends, or land cover changes over time. So the next thing we're going to quickly look at here is if you click on the categorical overview, this is going to give you some information about the quality of the data. So you'll get this this graph, this box and whisker chart, and it's kind of interesting because normally you'll have a box on where it says 1 here. There'll be a box here. There's only a line, and that's because there's only one pixel that is actually considered low quality. So if you click on this eye right here, if you see quality 0, that's the best quality. So that's where most of the data are here in this blue box. And then quality 1 is, it says there was a vegetation index produced, but there may be some quality issues. And so that this is just telling you that there's only one pixel that seemed to have some quality issues. All the other data have good quality. So then if you scroll down, what you're going to notice is another sort of box and whisker chart of the NDVI values for each of the sites. So on the x-axis, you have B1 through B8. On the y-axis, again, you have those NDVI values. And then you can see the range of values, not only between the sites, but within the sites, because it gives you the mean and the standard deviation, and also the number of sites, or number of pixels at each site for those years. One thing you can do, especially if you have more bad quality data, if you just click on the blue box, what happens is then you're only looking at the good quality pixels for this bottom graph. So again, if I look at the only thing that changed is this B1 site, if you noticed. If you look at all the sites, you'll see this B1 site looks like that, but then if you just click on good quality, then it changes a little bit. Okay, so that's the information you can get online just with this web tool. And now what we're going to do is analyze the data a little bit more thoroughly using Excel. So I'm going to go back to the Explore tab on the top. And then to download your data, you're going to click this Download tab. So I'm going to do that because I've already downloaded the actual file, so I'll bring that up in a second. But I did want to show you, when you click on the download file, you can get all of these data, but really the one that you're going to need is this one at the bottom here, the CSV file. That's going to be most useful to you because it will have all kinds of information in there. And I'll show you that in a minute. So then you just click on that, and then you can download it and work with it in Excel. So at this point, I'm going to bring up that file. If I can find it. All right, so once you download the file, the CSV file, and open it up, this is what it looks like. So there's a lot of information here, but we're only going to need a few of these columns. But before we do that, what we want to do is select the data points that are of good quality. And let me just quickly show you what's here and what's important. So in the A column, we have our points. And then In the D column, we have the dates. So obviously for each set of points, there's different years, 2005, 2006, 2007, and so forth. We have the latitude and longitude, and then the most important thing is column H, because those are our NDVI values. But before we do that, we want to just select the points that are good quality. So if you select the whole table by selecting on the little triangle at the top, and you go to data, here you can see I'm already there, data, and then select filter. You'll see the little drop-down boxes occur under each column. And so I'm just going to go to column N. And then you'll see a bunch of different selections here, decreasing quality, highest quality, and lower quality. We just want the highest quality pixels. So just select highest quality and then say OK. So then that is in N, as you can see, everything is just the highest quality pixels. And then what we're going to do is we're going to just copy and paste the columns that we're interested in into another worksheet. So I have already done that. So I'm going to bring that up. So you can see it. Okay, again, this is that. This is the worksheet with column N, just the highest quality pixels. And then what we're going to do is just copy over the site numbers, so B1, B2, B3, etc., the date, and then those NDVI values. Okay, so just copy and paste those from here. So that's column A, it's column D, and it's column H. Those are the three that we want, and we're going to copy them over into a new worksheet. Now, the first thing you're going to notice is that there are some blanks. So we're missing 2012 for actually a lot of the years, and 2016. And so what you're going to need to do is you're going to need to put in those dates that are missing. So you'll put in a row here, for example, for 7/1/2012 for your point one, for B1, and then just leave the NDVI value blank for now. We'll work, I'll show you what to do with that a little bit later. So you're going to go through your whole list and look at what years are missing. And if you go to page, I think it'll be somewhere maybe around 6 or 7 in your exercise, I've actually listed all the points that are missing, just to help you out a little bit, make sure you get them all. But you want to make sure you have all the years consecutive in there. And then again, just keep those NDVI values as blank. And then in order to graph this, we're going to have to change the format of how the data look a little bit. So what we're going to do, and I've already done it here, but we have instructions again in the exercise, is we're going to want to put the date in column A, so basically 2005 to 2019, and then you're going to want to put the values for each of the sites across the top. So what that means you have to do is you have to go back to this first spreadsheet and basically just copy and paste these values into something that looks like this. And you can still see those blanks, right? You can see those blanks that have occurred. And what we're just going to plot out the first 3 points. But what I did, so the graph looks a little bit better, is I just interpolated between the 2 points and put in, so kind of the halfway point in between the point before and the point after. And what that ends up looking like is right here, you can see for these B1, B2, B3, I just did an interpolation between the point before and the point after. You can also go back to your original spreadsheet file and take a look at what those NDVI values actually are to see if they make some sense, and you can put those in there. But again, this is just to make your graph look a little bit better. And then to make the graph, we have instructions on how to do that, but you basically just select these data, and we're just doing, again, band 1, band 2, band 3, with those interpolated data added. And then you're going to insert a chart at the top here, and we're just going to do this scatter chart with straight lines and markers. So I did that already. Here on the right-hand side, I'll make that a little bit bigger so you can see it. And then once you bring up the chart, what you're going to notice is that the y-axis is pretty big. Like the data range is very big. So, you know, one thing you can do is you can actually format the axis and change the values so it matches the data a little bit more. So if you right-click on the y-axis, you'll get way on the right-hand side here, this format axis, and you can change your minimum. And I changed it from to 0.5, ranging from 0.5 to 0.8. And that just allows you to see the data a little bit better. So as you can see from these 3 points, that clearly something happened between sometime between 2013 and 2014 with these NDVI values for all 3 points. And so that's indicative of that tree mortality due to the beetle infestation. So that's it for this particular exercise. I really enjoy this exercise, and I love the fact that we can do these kinds of analyses without any software at all. You know, back in the day, we used to have to download all of this imagery in order to get this information, and now we can do it in, you know, less than an hour. Which is fantastic. And so you could look at all kinds of different disturbances and changes. You can also look at polygons and you know, sort of larger areas if you're interested in that. So that's it for today. Thanks for listening. And Amber and I look forward to talking to you next week about Webtools. Thanks, everyone.
All right, so that's the end of today's lesson. I hope you guys have fun with it. Like I said earlier, I really enjoy working with AppEEARS. They've just done a fabulous job making life so much easier where we don't have to download data anymore. So at this point, I'm going to go ahead and start answering some of the Q&A. There's a few that have popped up, and I'm going to go ahead and answer. I guess I need to share my screen first. Hold on just a second so you can see the questions as well. Hold on. So I'm working in a different location today. I'm actually in Reno, Nevada, and it's beautiful here. And I have a little bit of a different computer setup, and so I'm having a bit of a hard time showing my screen. So what I may need to do, oh, Amber just said she shared with me. Okay, Amber's sharing her screen. That's better. So hopefully you can all see the questions, and then I'll just go through one by one as we normally do. And then if you have more questions while I'm answering these questions, please just pop them in the question box, or of course you can email us next week. So the first question is, what is the difference between forest disturbance and deforestation, and which is better in identifying forest health? So in my response, I said deforestation is just a type of forest disturbance and is typically caused by humans, so clear cutting and so forth. And forest health can be impacted by a lot of different things: drought, insects, and pathogens. So I don't know if there's more specific questions about looking at forest disturbance versus deforestation, but you can certainly use the AppEEARS tool to look at the timing of deforestation or look at forest health caused by other things such as drought, insects, or pathogens, which, by the way, tends to result in a much sort of longer, more subtle decline in forest health. So you have to kind of look over a long period of time. And actually, Land Trender is a great tool for looking at that as well. So the next question is, how long are the requests, so the AppEEARS requests, kept for, and when do they expire? That's a really great question. Honestly, I don't think I've ever actually asked that question of the AppEEARS folks. I did notice that mine tend to hang around for several months. So I don't know exactly the time period, and they may say on the website. But you can also, if you're concerned about it, you can also email them, and they'll keep your request longer if you want them to stay longer. They're very responsive people, and they're just great to work with. Is it possible to see the 8 points of NDVI at once for this example? So as you can see, you can't do it with the AppEEARS interface. You can only look at 1 point at a time, but then you can download the data and display it in something like Excel, as we did in this exercise, and then you're able to look at multiple points at once, which is why we did that part of the exercise. The next question is, how confident can we be that the positional registration of the image data is consistent between successive years when using point data? If 1 year's image is off by a pixel or more, we cannot trust the data to be valid. That is absolutely true statement. It's a great observation. We have to sort of I guess trust the data in some ways, which you're right is the downside of using point data versus, say, a polygon, which gives you a little bit more leeway in terms of the information that you're getting, and is probably honestly a better way to go is using a polygon versus a point because of that issue. Now, MODIS data have been corrected quite a bit, and so their positional accuracy generally is quite good. But if you don't trust the data or don't want to trust the data, I highly recommend that you use polygons instead of points. It's a great observation. Thank you for asking that. And then somebody, I think, joined us a little late and said, what's the start and end date range? So I explained that in order to include the years, you have to check that reoccurring box, reoccurring time period box, and then you'll get the option to add years into that. And then the next question, when you request a polygon from AppEEARS, how are the data aggregated? Now this is another, I knew this question was going to come because I've always only used points and not polygons, but I believe that they actually will give you the information for all the pixels within that polygon. So it's a ton of data. They don't aggregate it. That's, up to you to kind of aggregate it once you get all the data. So just to be aware that if you're going to choose a really large polygon, it's going to take a long time to process, and two, you're going to get a lot of data. The next question, it would be good to clarify which tools are available globally, and which are only in the US, North America. AppEEARS is actually available globally. So wherever MODIS data occur, which are global data, MODIS and VIIRS are both global, you can run the AppEEARS tool on any of those data. So they are available globally. Let's see, I'm trying to see if there's any more questions. Looks like there's not. Hopefully it's a pretty straightforward exercise for you. again, we aren't going to be using ArcGIS anymore. So the next 2 sessions will be some more really great web tools that you can use to process imagery. And also, I want to let you know that I think probably Tuesday, the next session on Tuesday, we're going to be giving you a link to a questionnaire, sort of a end of course survey that we would really appreciate if you could fill out. We'll be sending that link along in emails as well, just in case you don't get it and can't attend or something next week. So if there's no more questions, then we can end early today. You guys can go back to your work or whatever it is that you're doing today. And I hope you have a wonderful weekend. And again, please feel free to call us. Well, you can call us if you want, but send us email if you have any questions as you're going through any of the exercises or have questions about homework. So thank you so much for attending, and keep the questions coming. We love them, and we will talk to you all next week.